Hello students, we are going to look at lesson 6-4 today. We're going to split this lesson up into actually a couple days and a couple little smaller videos for you. So today we'll be looking at how to identify exponential growth and decay functions and applying it to real life problems as well. So standard 8 and 9 today. So the first thing is we know already that exponential growth and decay functions are going to be written in the equation of y equals ab to the x. And remember, a is going to be like that y-intercept, and b was that number that it's being multiplied by. So if everything was being doubled, it'd be 2. If everything was being, multiplied by 3, so like everything was tripled, that would be 3. That kind of idea. As we know, exponential growth or decay is a multiplication pattern to get from one y to the next y. Well, we're going to learn a little bit slightly different way of this format. And so if you look at the next core concept right here, we are going to see this equation that we're going to use instead. And it's the same format, and that kind of is noted right here. It's the same format as this a b to the x. The difference, though, is when we're dealing with a percent change, by percent increasing or percent decreasing. In this case, it's going to be growth, so we're going to be looking at a percent increase problem. We're going to replace b with this 1 plus r idea. And r is this rate of growth in a decimal form. That's really important. If you don't have it as a decimal and you're giving it to as a percent, like so for example, let's say it's 2%, how do I convert to a decimal? Is I'm going to divide by 100. So that would become 0.02 instead of 2% if r was 2%, okay? And then t instead of x right there, we're going to use t instead. Okay, and that's once again just kind of mentioned to you there. So we're going to learn how to apply this to an actual story problem in a minute. So let me just kind of quickly clear things out and move this along. Oops, not what I wanted to do. That's all right, we can clear it out. Oh, perfect, I'll just move with it. All right, so here's our first example. The inaugural attendance of an annual music festival is 150,000. The attendance Y increases 8% each year. So step A is to actually just write an exponential growth function. So I'm going to put the basic format a second. It was y equals a1 plus r to the t. So we're going to fill those things in. So A is our starting amount, or our y-intercept. So they said that the inaugural attendance of a music festival, inaugural is kind of like the starting amount. You've heard of like inaugurations of a president. That's like their beginning of their term. So this is the beginning when they started the first year for this festival. That was our A. Okay, so this is going to be our A. And then it says that it's increasing by 8% each year. That's going to help us with our R, but our R is not going to be 8. We need to convert 8% to a decimal. So once again, you're going to divide that by 100, or some of you might think of it as moving it 2 decimal places to the left, and that's going to give me 0.08. And so now I have my A, and now I have my R, and that's the only things I need to write my exponential function. So it would look like y equals 150,000, parentheses, 1. You can do the 1 plus 0.08, or you could, and I'm going to switch that up in a second, and then to the t power. But I would actually simplify it one step further, and I would say 150,000 times 1.08, because I added those two things together to the t power. Okay? And then the next thing I would do is, oops, sorry, I'm learning how to use this thing. There's my eraser. All right, so the next thing I'm going to do is I'm going to go ahead and answer part B question, if I can get rid of that. All right, so the second question right now is, how many people will attend the festival in the 5th year? Remember that T is years, so in this case, for B, for part B, we're told that T equals 5. So all we're going to do is put in, for this, we're going to plug in 5. So you can use your calculator for that. And if you do, some of you have to be careful on your calculator, that if some of you have a calculator that doesn't do order of operations for you, so you technically would want to do this first on your calculator and get that answer and times it by the 150,000. Some of you can plug it all in your calculator at one time, but generally speaking, you get a decimal answer here. So I get 2004,073-ish, approximately. Because it doesn't make sense to have how many people. It doesn't make sense to have a decimal person, so I would use rounding rules on this one. Okay, so that would be our answer, and then this first one right here was our answer for A. This is a huge idea and concept, so we're going to try it one more time with an example. And so this example is an extra example. Oops, I gotta undo that. An extra example like the first one. Okay, so extra example here. We have a website has 500,000 members in 2010. Go ahead and write out a function for this that the number y of members increases by 15% each year. So you want to definitely look at that right here. It's increasing, and that's I know it doesn't matter now because we're going to see a bunch of growth ones right now, but it is important because they're going to get mixed together at some point. So it's increasing. So I'm going to write my equation for that. So y equals a, then it's 1 plus r to the t. So remember, a is your starting amount. So hey, it has this many, and this was going to assume as our starting amount here. And then it increases by 15%, so that 15% is going to become my r, but I have to convert it to a decimal by dividing by 100. That doesn't look like a division symbol, sorry. So that gives me 0.15. So I'm going to go ahead and write this over again. And so my equation is going to be y equals 500,000, 1 plus 0.15. So I'm just going to go ahead and do the math there. Like I did those two things already. 1 plus this gives me 1.15. And then to the t power. And then for part B, let's see here. How many members will there be in 2016? So I have to be careful here. 2016, that is how many years? Like T is T years, right? But it's after 2010. So that would be 6 years, right? 2016 minus 2010 would give me 6. So T equals 6 there. That's a funny looking 6, sorry. So I'm just going to now use my equation, and I'm going to go ahead and plug in 6 for that. So once again, some of you are going to need to use your calculators a little bit carefully and do this part first on your calculator and then keep that answer. Don't round anything yet, and then times it by that 500,000. But try it on your calculator, see if it matches my answer here. I gotta quick find my answer. Okay, they're totally rounding in the book right now, so I don't really know how close this answer is right now. But about that, if you did some good rounding, like for example, on the previous one that they did, they rounded down to just 100 or 204,000. So they skipped that 73 people that they had at the end. Example a second.